myself, but I'm mostly just kind of hosting and switching between our various esteemed guests today. We just got a couple of housekeeping things. We are, of course, welcoming questions very much. If you've got things you want to ask, comments you want to make with our presenters, please go ahead. If you can use the hands up function to do that, that would be really helpful. Or if you like, you can just chuck your comments and your questions into the chat, and I'll keep tabs on that as best I can. Probably with the exception of my own spot, because trying to keep tabs on that with your spot might be tricky, but we'll see how I get on. A question about registering, that's fine. So I think that can get picked up and that will not be a problem. There we go. That's an email address at highland.gov.uk. Yep, Stephen, thank you very much. Okay, so we're going to go to our first presenter, which is Phil Wooten from Royal High. As I was alluding to earlier, I'm actually sitting in Phil's old classroom here at Kirkcaldy High, because Phil taught here before he went to Royal High. So Phil, here's your slides and I'll let you go.
Well, we'll skip the first slide. That's just contacts if you need to get in contact with me. It's great being first, isn't it? It's just, I thought it was Grant who was going to be first, but turns out it's me.
Oh, have I messed up already?
You have indeed, but I was too polite to say it.
Right, well, that's fine. So let's go to Grant instead, and we'll let
Phil get
it back together. That's a strong start, everyone.
Okay, good evening. As you probably now know, my name's Grant Mackenzie, and as I look out the window above me, it's maybe not such a good evening after all. Anyway, it's very nice to be with you. For almost 40 years, I taught chemistry, and the last 25 years of which I was principal teacher at Lenzie Academy. There's absolutely no truth in the rumour that there were actually only 4 elements: earth, air, fire and water when I first started teaching, but it's been a long, if not successful, career. Anyway, I'm retired now. And to be quite honest, it's absolutely brilliant. I would thoroughly recommend it. I did the Aldi shop this morning. It's been great. And this is a highlight of my week so far. So a few years ago, my youngest son, Fergus, came home from primary school. And his teacher wanted to know if I could go into the primary school and do some methane explosions. So I asked my son Fergus, did they have any gas there? And he said no. So that was a bit of a problem from the off. So I went into Lenzie Academy and took a few videos of me doing a few demos. And I'm not going to spend time. We don't have the time to show you the demos just now, obviously. But these are the demonstrations that I did. So I'm going to quickly kind of talk through these. Many of these are well known to chemistry teachers, but I thought I'd just give you a few tips and maybe some of the pitfalls that I've encountered along the way. Obviously, a lot of these are online, safety instructions, video clips, all sorts of stuff is online, so it's very easy to find. These are well known demonstrations. So if we could move on to the next slide, please. Okay, well, there's the famous exploding can demo, familiar to a lot of people. Metal can, hole drilled in the middle, and you can't see from the photo on the left, but there's a lid that also has a hole drilled in it. The natural gas is inserted through the hole at the bottom, and the can is usually placed on a tripod stand. Safety screen, pretty important as well. And the escaping gas from the hole at the top is ignited. It'll start as a yellow flame, and gradually the flame will burn down inside the can, and an explosion with the lid blowing off should ensue. The problem I had with that when I first started teaching was that I was never quite sure how much gas to put into it. So the first time I put too much gas on it, and it must have taken half an hour for the gas to burn down. And you can imagine the pupils sitting there. You're giving it the big build up. It's going to explode. It's going to be fantastic. It's amazing. And they are twiddling their thumbs. Bang. Thank you very much. Tumbleweed is kind of blowing across the classroom. So the tip I would probably give for that would be set it up, but set it up at the side of the class. Set your expectations as being very low. Say to them, well, I don't know if this is going to work. I'm not too sure. No chance. It'll never work. But then I'll try and get them to go and do some quiet work on their own, so they almost forget about the demonstration at the side. And while they're doing their, combustion question balancing equations, suddenly there's a loud bang, and you know, a few changes of underwear required. Thank you very much. Bang again, and that kind of saves many blushes and improves discipline within the classroom as well. They're not waiting for this explosion to take place. If I could move on to the next slide. This is the methane rocket demo. I think this video is actually on the Royal Society of Chemistry website. This is probably my favourite demonstration in terms of the methane one. If you look at the photo on the left, a small plastic drinks beaker has been immersed in or submerged in a trough or a basin of water. Oxygen is inserted into the plastic container, and about 2/3 of the water is displaced with oxygen gas. The remaining third of natural gas is inserted, and so you have the mixture of oxygen and natural gas. If you move then across, stopper it, of course, first ensure that you've picked a stopper that is the right size before you do the experiment. But stopper it to take it over to a launch pad, which is usually an open book that has no further use, maybe some old ChemCord textbook, I don't know, that might catch fire. And if you maybe use a folder and set it at the correct angle and remove the stopper, ignite it, and the rocket should shoot across the classroom at a target. I tended to use a Pudsey bear that sat on a shelf in my classroom for many years, and having done it for about 40 years, Pudsey was totally safe. I don't think I hit poor Pudsey once. I hasten to add, I didn't hit any pupils either. Everyone was safe. Safety screens were involved. I'll talk about more safety later on. If we could move to the next slide, please. The next slide, very well known, methane bubbles. Again, a trough or a beaker, a basin of water, some detergent added to it, natural gas from a gas tap bubbling into it, and scoop up the gas, set it on fire, keep your arms at arm's length. Obviously, normal safety precautions apply. There is a more spectacular version of this by bubbling oxygen gas in with methane gas. If I could please urge you, do not try to set it on fire when holding the bubbles, when doing the one with pure oxygen. By all means, scoop up the gas, the bubbles, maybe place it on a heat-resistant mat, stand well back, meter stick with a burning splint at the end of it. Should get a nice loud bang. So again, probably ear defenders are recommended for that as well. So we could move to the final slide. This is a picture of me. It stills from like the video I took on the demonstration I did when my son was in at Lenzie Academy. I think he was doing the filming. The plastic bottle has the mixture of 2/3 oxygen, 1/3 natural gas. I've just removed the stopper, safety screen separating me from the classroom, ear defenders on. And as you can see, the still shows in the second photo, the rocket takes off. Pudsey is just out of shot. And again, he survived. I've never hit poor Pudsey bear once. But that was a perfect experiment. There was one time it didn't go quite so well. I set up the experiment, removed the stopper, and absolutely nothing happened. Pupils very disappointed, grumbling, moaning. You said it was going to explode, sir. This is rubbish. I wish I'd done biology. All the usual gripes and complaints. Couldn't quite figure out what it was. The mixture of gases just didn't seem to be escaping from the bottle on the launch pad. So I thought, just to check to see if maybe all the gases had escaped between me removing the stopper and trying to light it, I took the burning splint and stuck it inside the plastic bottle. There was a huge explosion. The plastic bottle shattered into 1,000 pieces. No one was hurt. Fortunately, safety screen did its trick. Although if I was doing it again, I'd probably put another safety screen on the other side for me, so no shards of plastic bottle would hit me. But I survived unscathed. But I was curious to know what happened. That said, I got a huge round of applause from the pupils, lots of cheering and whooping, and the usual questions. Oh, can we do it again, sir? Please do it again. But I kind of was curious to know what happened, and I think I kind of figured out later on. Previously, I'd been doing the methane bubbles. And I think when I was filling up the bottle, although I washed out the trough and the basin, there was still some detergent remaining. So when I was using the same trough to fill the oxygen and the methane into the little bottle, there was some bubbles I hadn't noticed in there. So when I removed the stopper, the oxygen and methane was trapped in the bubble inside the plastic bottle. So it wasn't escaping. So obviously when I then stuck the burning splint inside, then the oxygen and methane exploded along with the container. So really, you have been warned. Please go and practice these safety precautions. Very, very important. But if you can do that, practice, practice, practice. 3 great experiments to hopefully make the pupils enjoy chemistry. Thank you very much.
Oh. You're on mute, Paul.
I'm muted. Sorry, guys. No, that was grand. Thank you, Grant. It reminds me of an experiment that I do, which is a hydrogen and oxygen bottle, and I do it in a fizzy drinks bottle and drop in palladium black catalyst. It's a 10% palladium black catalyst, which is actually a lot cheaper than you might think. There's actually a video of it on YouTube. Not that I did it, but you'll see me in the video because I filmed it. So I've just put that there. So there's another sort of explodey demonstration if you wanted to have a wee look at that. And you can get a laugh at me running away from my camera in that particular video. So enjoy that. No, that was grand. Thank you, Grant. Right, as promised earlier on, we are definitely going to go to Phil Wooten now. So Phil, if I pull up your slides, and
Okay.
it's all yours.
Right, after that explosive start, I'm just going to give you a couple of practices you can do where no one gets injured, no explosions. It's just basically when you're teaching the hydrocarbons unit in National 5, I noticed there's lots of opportunities to go back to the classic card games and kind of put your hydrocarbon, hydrocarbon topic on it, for want of a better word, right? So basically, when I started in Kirkcaldy, I found that the students were more engaged if they had some kind of activity. I mean, you've all seen the reaction when you get a Kahoots out, okay? So the message is clear. They do like games, but I like games where they're learning. So my hydrocarbon, the first one, if you want to click on, Paul, it's just like I said, click on one more. I'll take control if you want, Paul. Not that you're not doing a great job.
I was going to say, just take control.
Yeah, okay. So hydrocarbon snakes and ladders, basically, then I've taken on control. Yeah, basically I set up a pack of cards. On one side, you have the name of the alkane or the alkene. The other side, you have the molecular structure or even the molecular formula. So the way it works is the student that's got the cards says to the opposition, right, you can either give me the name of the alkane or alkene if I give you the molecular formula, or if I give you the name, you can give me the molecular formula, vice versa. So they have a choice right away of which side they're going to respond with their answer. But the nice thing I liked about the hydrocarbon snakes and ladders is you use the number of carbons in the hydrocarbon as your dice for the hydrocarbon snakes and ladders. See, you never see that coming, right? It's more about, obviously, if it's butane, you can then, if you get it right, move your dice on the snakes and ladders board 4 places. Methane only lets you move 1 places. You get the idea. So they're kind of acknowledging the names of the hydrocarbons, the chemical formulas of hydrocarbons, the difference between alkanes and alkenes, and they're doing it without even realizing, because they start to want a larger, octane. They recognize right away. Get some 8 moves on the snakes and ladder board, and also kind of make the reference to the ladder is like double bonds, but I guess that's stretching it a wee bit. But there's a connection. There's always connections, right? So hydrocarbon snakes and ladders, I have all the boards. I just took a Google snakes and ladder board, and I have the cards available. So if anyone wants that, if anyone's watching, just get in touch with my email. I'll put it in a straight attachment to you, and you'll have to do all the laminating and preparing your snakes and ladders boards yourself. But I can tell you that it does work in the sense that Vex very quickly, subconsciously gets them familiar with alkanes, alkenes, the naming conventions, and the molecular formulas. You could do it where you do full structured formulas one side and names the other side, and that would get them familiar with drawing molecular full structure short and structured formulas. It's kind of like a quiz, but at the same time, as I say, using number of carbons as your die on the snakes and ladders board. The other thing I do every year when I get to fractional distillation with the S3s, I know fractional distillation is not so much in National 5, but more for S3s, is we do a fractional distillations Happy Families set. So basically they have a jumbled up set of cards and they have to put them into the families. And that basically is put them into the fractions. So you have the carbon length, you have the name of the fraction, and you have an everyday use. So there's a picture card that might show a plane or might show a camp stove. And then you have the size of carbons, C1 to C4, and then you have the names of the carbons. And they have to basically untangle all the cards and put them into their various, it works to about approximately 6 or 7 happy families. You go around, and if one of them's not in the right family, say you're not right, so they've got to mess around with the cards again. But it's a nice, easy, relaxing way to kind of get them engaged in fractional distillation. And I've used that ever since I came up with that one, and it's been quite popular, to be honest. So fractional distillation, happy families, hydrocarbon snakes and ladders. I've used them for the last 10 years at Royal High. The last one, I'll be honest, I still haven't used yet. I've used it, but not in hydrocarbons. But when I was doing this slide, I realized you could use it in hydrocarbons. And it's a simple concept of snap, right? We know that when you have two the same, you press snap. And I realized that, I've used it like atomic number, symbol, atomic element symbol, number of protons, number of electrons. And if someone put down, for example, a sodium card, the next person puts down 11 protons, you can go snap. But you can only snap if you know the atomic number of sodium is 11, right? So it's worked really well there. But it would also work well alkanes, alkenes, alcohols, and carboxylic acids, because you can mix up cards of molecular formulas, molecular structures, names, and if that molecular structure matches the name of the next card, a candidate can go snap and get all the cards. Now, they're playing snap, but they recognise it on the basis of their chemistry knowledge, right? So it's a really nice way of, again, promoting the chemistry knowledge into their head, getting them familiar with their terminology and names. And you could have one master card that says saturated, and that's going to snap with any of the alkanes, right? You could have another one card, magic card, that says unsaturated, and you can snap that with any of the alkenes. So I think the snap concept of the classic card games would work pretty well in a class. And there's no safety sheet has to come with this. It's just cards. The worst to go and get is a paper cut. And that's it. And I think I've done that, Douglas, in my 6 minutes, I promised.
That's grand. Yeah, there's some mention in the chat of element top trumps as well. And I can see that Stephen's posted a version of that, and I've just posted the version that I've got as well, which is the visual elements one. No, that was grand. Thank you, Phil. And if you can, Phil, could you drag some of the materials for that into the chat so people can pick them up?
Oh, I'll try that now. I'll put my camera off because I'll be tapping away at my screen.
Tapping around. Yeah, no, that's no bother. But yeah, if
not, I'll send them. What I'll do, Paul, if I can't, because this is a new iPad we just got off the school today. We're one of the new schools that's going. I think we're going Apple Classroom. I think Empowerment is called. I'm not familiar with this iPad other than opening up the Teams at the moment. But what I will do is I'll email you all the content I've got, and then if anyone gets in touch with you, you've got it ready just to drop whatever you want to drop.
Yeah, well, I've got all the presentations, so if you chuck stuff my way, then I can package it all together and give it to Stephen, and that can be distributed to everyone. That's fine. Okay, so thank you very much. No, thanks, Phil. Okay, we're going to move on to myself. I'm going to just talk you through a couple of things that I've just kind of noticed about my own practice, and a couple of things that I've sort of tweaked and changed. I'm quite into really simple changes that you can make that can make a surprisingly big difference to not only yourself and to the kids. And a couple of things kind of sprung to my mind on this business of reflection, which we were discussing last time we did a meeting like this. We had a fairly long chat about reflection, and just the sort of changes that I end up making when I reflect on things. And just this one came to mind. This is a starter question that I've used on a number of occasions, which is 2-methylbutane, and then asking questions like how come 3-methylbutane, 4-methylbutane, and 1-methylbutane don't exist. And I was looking at some of the papers and the kind of questions that the kids were getting, and realised that when I'm asking questions like this, I should use the phrase structural formula, because that's the phrase that's used in a lot of the SQA questions on this particular topic. So stuff like that can then make a surprisingly big difference, because then when the kids sort of encounter these things in an exam, it's suddenly not a strange thing. So I'm trying more and more to kind of pick those things up myself. And another little sort of reflection thing that occurred to me when we were talking about this last time round. So I'm going to show you the sort of evolution of a slide over a 10-year career. So starter questions are a big deal for me, and the kids in my classes all know that the minute they walk in my door, there's a starter question to complete. So they should pick up one of these bad boys and get the starter done as quickly as possible and without being prompted. And this is a sort of an original version of a starter question that was obviously to do with rates of reactions. And you can see the aim of the lesson is at the top there. And you can see the starter question I've given the kids is to use the data to calculate a rate of reaction. And that was the original version of it. Later on, it got modified. And the modification was to take it from a question to a command word. And again, similar to the previous example I was showing you, it just occurred to me that actually I should be trying to write as many of my starter questions with command words as I possibly can. Again, just to get the kids used to that. And then later on, it changed again. And it went from being 2 times that I'd specified to 2 times of your choice. And that actually allowed the kids to pick times that they thought were easier or pick times that they thought were harder. So maybe someone who's struggling a wee bit, I might direct them to say, okay, why don't you do 0 to 10? And then somebody who's finding actually they're doing all right, I might say, okay, well, why don't you do, say, I don't know, 60 to 100, but that's not too bad either. Why don't you do maybe 40 to 60 as a sort of tougher kind of shift? So it allows me to direct certain kids to certain time periods. So it changed to that. Later on, it changed again. After I noticed a couple of things that were sort of barriers. The barrier to kids a lot of the time in my classes is actually just getting started. And so actually I found that if I said to begin with to write down the equation, and that actually got them started, then they had the equation in front of them. I also noticed that they were struggling to figure out the meanings of the triangle and what quantity meant. So I actually put that into the starter question as well before you actually get to the calculation. So that was another sort of reflective change that occurred. Then it changed again, and it became write down the equation from page 3 of the data book. So I started actually specifying, because the kids were going, Ken, where's this equation? What are you talking about, Dr. Murray? I was getting a hold of that. So I started specifying the page of the data book. And then most recently, we've got one more change before the most recent one. There it went to being average rate from being rate, because I suddenly noticed that was really throwing the kids, because again, the questions asked about average rate. And it's interesting to notice in the new data book that has now been specified. I was getting all sorts of crazy answers in exam questions and test questions on this, where the kids would like take all the masses and add them all up and divide by the number of masses. I was getting all sorts of things going on, because actually the first time they were encountering average rate was when they saw it in the exam, because I'd been saying rate all along. So it changed again. And the most recent change is this one here, where I've now started putting my questions in purple, because that actually differentiates between the aim and the questions they're supposed to do. Because again, kids were walking in and trying to answer the aim, because you can't answer the aim because we've not done the lesson yet. Although that aim actually you could, because it is more of a continuation, but hey ho. And so they ended up going in purple. And you'll notice at the bottom, there's also a question sitting at the bottom for anyone who's really struggling and actually just needs something really simple option that I can direct them to, just to get them kind of started in the lesson. So it was interesting, as I say, last time we did one of these sessions talking about reflection and thinking about the slide and looking that it's gone through 1, 2, 3, 4, 5, 6, at least 7 generations over my 10-year career. And it's every time it's in the basis of reflection, it's the basis of actually looking at what's going on in the classroom, what are the kids doing, what are the kids saying, and then changing what I'm doing as a result of that. So I thought that was an interesting little thing just to let you see. A couple of more sort of things that you might want to use. We talked last time about things like use of wrong answers. And an interesting example of use of wrong answers is this particular example here. These are all answers to do with increasing temperature and rate of reaction again. And these are all answers that I've had from the kids. And it's a kind of look at these answers, which ones are going to get you marks in the exam and which ones are not, which ones are actually just kind of not really saying any chemistry at all. I know the kids tend to spot that number 5 is probably the one that's going to get the marks. But at the same time, I then go, okay, what's the problem with all the others? Well, the problem with question 1 is it doesn't really say anything at all. The problem with question 2 is because it's not saying what they are. It says they move faster. What do we mean? Do we mean particles or do we mean atoms? What are we talking about? We've got a kind of decent answer at the bottom with question 6 there. The rate increases because the particles move faster, but it's not a complete answer. And then answer number 4 there is actually talking about concentration as instead of temperature. So it's just a kind of wrong answer completely. But again, it's chucking these out and say, okay, take 2 minutes, 3 minutes in your teams, because it's all teams and desks of teams in my classroom. Take 2 or 3 minutes in your teams to have a chat about these, see which ones you think are correct, which ones you think are incorrect, and what can you do to make them correct. And that's actually the most interesting question of all. And I had another wee example of doing a similar thing just last week. This was last week, great idea. We were doing classic electron arrangement diagrams, and I could see the usual kind of wrong answers or not quite right answers appearing around the room. So I made this up. I actually did this while the kids were working, and just basically nicked a couple of their answers and chucked them onto the slide here and saying, okay, what's the problem with some of these? And so things like obviously carbon hydride, it's just completely, it's missing 3 hydrogen. But even things like the hydrogen sulfide one's an interesting one, because sometimes, and it's really common actually, the kids are not clear enough about what the electrons actually are looking like there. And so I was saying, okay, you might be okay with that answer, but at the same time, I'm struggling to tell, particularly at the top there, whether that's an electron or whether your pen's just slipped. And then you've got hydrogen iodide, I've given the lower case. So things again, trying to get the kids to say, okay, what's wrong with these and what can you do to make them better? And I've got 2 other things I'm going to show you. One of which is, again, a new little tweak that I've made just over the last couple of weeks, and I'm still experimenting with this one. A lot of our kids really struggle with drawing graphs, find drawing graphs really, really tricky, and particularly down the bottom end, although having said that, even 3rd, 4th, and I'm noticing 5th years still struggling with this. And you'll do a sort of graph making activity, and some of the kids will do all right and some of the kids won't. And this is an idea that I came up with, This is an idea that I came up with saying, okay, so here's my data that I'm going to use for my graph. And I don't know how well you can see, but the top 1, 2, 3, 4 data points are bold and the bottom 3 are in bold as well. And kind of pointing out to the kids, okay, these are the ones to plot as a minimum, because those are the ones that are going to be quite nice to plot because they're all sort of nice numbers. They're all sort of 5s and 10s and 25s and things like that. And when I do the scale for this particular graph, it's going to be a dead easy 30 along, 5 up, and that's actually a marked point. That's actually one of the points marked on the axis, so that's a nice one to spot. And then if you're feeling brave, you can have a go at plotting the points at 120, 150, 180 and 210 and make those, okay, those are the optional points. But the ones that I'm saying you kind of have to plot that I'm going to be looking for are the top 4 and the last 3. And those are your sort of bare minimum. And it was interesting, I was doing this with a first year class today, and a few of them were generally taking that. A lot of them were going, okay, I'll just do the top 4, bottom 3, and that's kind of where I am right now. But a few were having a go at doing the sort of 120, 46. So is that maybe half a box, Dr. Murray? Or maybe that, okay, that's good. We can have that conversation. And so that just little bit of differentiation was kind of helping and just making this less of a stressful experience, because I'm really conscious that a lot of the kids find graph drawing a really stressful experience. Like it's just horrendous and it's just, dots and lines everywhere and funny paper with blue lines in it, and that just messes with my mind. So trying to kind of make it a bit more accessible. And I'd say I'm still playing with this one, but it actually works quite well. The final little thing I'm going to show you is this. So this is one of a number of little stories that I have written. One of the things that I notice about my kids here is that they really struggle to pick out information from questions. So I kind of took that and said, okay, let's just cook up some questions where most of the information is actually completely irrelevant, and the job becomes then to pick out the information from the question and do a recalculation. So I started writing these stories about myself and my niece, who at the time was more like 3 or 4. She's now 8. So most of these wee stories have got a little thing that Heidi and I have been doing. And there's always daft things, and usually it's me that comes off worst, because usually I'm drunk under a table and Heidi's being very sensible. And at the end of it, there's a calculation to do. And the aim of the game is, because you'll see them sort of panic the minute I put that up on the screen. I'm going, okay, but remember, most of what you're seeing is actually irrelevant. Your job is to try and pick out the information and see if you can actually use that to do the calculation. Most of them are written at a higher level, but they can be tweaked quite easily to be at National 5 or even Advanced High level if you wanted to do that. So I'll see if I can share that into the chat, and if I can't share that into the chat, I'll chuck them into the folder with kind of everything else that's going to get created. So if anybody wants to play around with my Heidi stories and change them for your own children or your own nieces and nephews or whatever you fancy, feel free to do that. So yeah, that's my wee bit. Just again, looking at things, little tweaks that you can make that make a surprisingly big difference to yourself and to the kids as well. So yeah, thank you, Colin. I hope that was useful to folk. So we're going to switch to our next presenter now. Now, because I'm presenting, I actually don't know who that is. It's going to be Ian. So we're going to go from Kirkcaldy to Pennycook. So I'm actually going from where I work to where I was brought up, although I wasn't at your school, Ian. So your school's just the smelly poo school. But yeah, anyway.
Charming, charming.
It's all yours.
Yeah, just skip that slide. Perfect. So you can see that I've been teaching a wee while, not as long as some of our other colleagues on the call. I've been at BSLAC, previously I was at Last Wade. Just in the last couple of years, things have got quite busy. So the last couple of years have obviously thrown many challenges for learners and teachers. I've actually been really lucky to collaborate on a variety of projects over that time. It's actually really revitalized my approaches, and it's ended up generating many fresh strategies and resources for delivering and also for enhancing pupil performance, especially in the advent of all the iPads being issued and Chromebooks being issued to students. At BSLAC for many years, we've used past paper questions as the basis for formative assessments, both in class and for homework. These provide students with experience of various types of questions and improves their competence and technique. And it actually gives them the opportunity to review those types of questions without the stress of it being an exam. If you skip to the next slide. Now, as has been shared a lot over the last couple of years, there's been loads of really high quality Google Forms and MS Form quizzes, and many of the links to them are found on the National eLearning offer, okay? And what I think is that really this will be key to improving success with 6-in-1 style questions. If you skip to the next slide. By actually using past paper style questions, it highlights to students the time and work required to complete the multiple choice questions. They're really good as preliminary at the end of sessions, part of homework, or perhaps consolidation. Obviously with them, if you set it up a certain way, the students can actually get instant feedback, and we were using it today as part of their revision. If you do the next click. Now, as part of eSchool, we use these during the live sessions, and you can see how students are getting on with different questions. And they provide instant feedback, and also, really importantly, allow us to find the questions or the skills or the areas of the course that students are really struggling with. So you can see the top question they've really struggled with, the second one they find a bit more straightforward, okay? But again, if they get experienced in problem-solving questions at this point, they're a lot more confident when it comes to the real deal. If you go to the next slide. Over the last 18 months, it's been phenomenal the amount of resources that are being generated. Miss Adams definitely led the way a long time before all of this kiosk hit. But there's a real increasing quantity of high quality resources now. And one of the main ones, if you click to the next slide, is WestOS. Now, most of us can get access to this from the Glow Launchpad. It was originally set up by the West Partnership, so that's the West Improvement Collaborative. It's available to most schools. There is a few students who can't get access to it yet. And another option, I know in Edinburgh Council, they use the ClickView login to get hold of it. Now, we're really lucky because there's narrated lessons for most, if you click the next slide, sorry, for most senior phase subjects. Oh, missed a slide. Anyway, there we go. So you can see that most subjects have something there. So next bit, next slide. So biology and chemistry have been leading the way with most topics. There's a few holes, but most topics are populated in some way for National 4 all the way through to Advanced Higher. The hope is that it can be used for delivery to students who have long-term absences. They might be stuck in hospitals. They might have mental health issues or whatever if they're learning remotely. It's also been really effective if there's a teacher absence. So, for example, I was off with COVID in September, and I just sent my students onto this. And obviously, pupil isolation stuff, this has been really useful. Now, starting with higher in Nat 5, there is extra resources being added to these. So you can see there that there's summary notes, there's practice questions with a marking scheme, there's an MS Form quiz, there's the link to BBC Bite Size, and conveniently, for my next wee bit, there are linked to practical videos, if that's been appropriate, okay? Just click through, that's fine. So during the first lockdown, practical skills and experiments were a priority for remote delivery. When we weren't allowed in school, it was really difficult to say to students, right, well, you need to understand this skill, you need to know this experiment. Now there's loads of experiments out there, there's loads being generated. So there's a whole batch. I've added the links onto the chat. So there's ones from the Royal Society of Chemistry, there's STEM Nation, which was a collaboration between Education Scotland and Colin McGill from Edinburgh Napier University, and there's more there from CERC. Chris Lloyd was mentioned earlier in the chat, and obviously there's quite a few on BBC Bite Size now. So those videos, together with other ones by Martin McCarthy, Adrian Allen, Miss Adams, allow students to review many important experiments and the practical skills. They're definitely not a replacement for doing them in class, but they're actually really useful as an introduction or a later recap. They might also be useful to early years teachers, highlighting the actual learning objectives and specific skills that are needed by students. Okay, thank you so much for listening.
That's grand. Thank you, Ian, very much indeed. Yes, some lovely stuff there. And as you say, it's amazing the kind of amount of stuff that COVID has been the driving force essentially behind the development of, and it's fantastic what's out there now. And thinking back to being in Pennycook myself as a kid, what I would not have given for the access to some of this kind of stuff would have been amazing. Right, we are going to go to our next presenter now, which I'm just trying to find the right presentation. I think we're going to Ruby next. Yes, we are. So Ruby, I will just pull up your presentation and it's all yours. There we go.
Fantastic, Paul. Thank you. Am I okay just to take control for that one?
You can take control. That's totally fine by me.
Excellent. Great. Okay, folks. Hello. Nice to see you all. Some familiar faces here, and nice to meet everyone else that I haven't met before. My name is Ruby McEwen, and I'm in my third year at Ross High in East Lothian. I'd done my probation year at Craig Royston before that. So I think compared to some people on the call, I'm relatively new to teaching, and I've actually really enjoyed everything that I've heard so far. So thank you so much to everyone else who's shared, because I'm feeling quite inspired. And this is a stereotypically difficult time of year to feel inspired. So thank you for that. Excellent. So when I came to Ross High, I was really excited because I was going to be working for Wendy Adams, as in Miss Adams Chemistry. Now, she's had a couple of shout outs already during this sort of meeting today, because she's done lots of YouTube videos. Now, I would absolutely recommend, if you've somehow missed them all so far, you need to check them out. There's basically YouTube videos for every section of the National 5, the higher and the advanced higher course, and they're great to post maybe alongside homeworks, things like that, just to help pupils kind of just be able to take their time over concepts that they've maybe struggled with a little bit in class. Something that, and this is kind of almost a disclaimer, something that I like a lot about this department is that there's a real focus on consolidation and retrieval practice with our pupils. So what I'm going to show you today is partly activities that I've come up with partly activities that the department's come up with, and we all kind of share them and use them together to really build consolidation and retrieval practice into our everyday practice in the department. So I'm going to talk a little bit about making that a bit more fun and engaging for the pupils. So this consolidation is really important. You'll know this already for an S3, National 5 and higher in particular. Some degree of repetition is absolutely essential to build their confidence to tackle things like calculations or the sorts of questions that are very procedural that come up every year. You're almost guaranteed they'll come up. You want them to know how to tackle those. And you want them to feel confident in that, because what I've noticed with a lot of our pupils is that if you tease it out of them, they know what to do, but when they're staring at the blank page without it in front of them, they can really struggle with getting started with that. So we find that just going back over these concepts regularly can help a lot with that. Something that I discovered early on in teaching as well is that they can become disengaged if we just give them repeated questions in their jotter with a textbook. So we try and get a little bit creative with it. Textbooks are fantastic. They're very, very useful. But if you're doing that, you know, every second lesson to consolidate, they're going to get a little bit fed up sooner or later. And we want to think of ways that we can keep them engaged and thinking about it. So I'm just going to show you a few different techniques that we use. And then I can send the files to Paul and he can send these out with everything else for this meeting as well, so that you've all got access to them too. So the first thing that I want to show you is a Hess's law loop. Now you could do this for any type of calculation, and it's kind of a bit like dominoes. So you've got a card, it's split into two sections. One side has an answer and one side has a question. And the idea being that the answer to a question will be on a different card. So you place that card next to it, and then you can build it round to form a nice loop. What I like about this is that it's very easy to convert questions to this format. If you have a list of questions and answers, you can just copy and paste it into this format and it works beautifully. What I also like about this is that it's effectively multiple choice. There's a finite number of answers for them to choose from. And for Hess's law questions, when we're practicing that and starting out at higher, I think that's a good thing for the pupils, because they can get a little bit drowned in all of the different places that those calculations can generally go wrong. You know, there's a lot of places where if you don't flip a number or if you don't multiply it, there's a lot of areas where we can make a small error that affects our final answer. So having sort of 9 or 10 answers to choose from can help focus them, and it can help them do it by process of elimination and then go back and work out maybe where they did go wrong. So if they find that they're maybe, you know, their answer's out by 20 kilojoules, right, let's figure out why that is and work backwards. It's also nice because as they go through the questions, there are, of course, a reducing number of choices each time. And so they feel like they're kind of getting rewarded as they move through it. I found this to be a real breakthrough lesson with my hires with Hess's Law, because it meant they really concentrated on the 10 questions for 20 minutes or so. And a lot of them felt like they made a lot of progress with that, just kind of getting to hammer through that and consolidate that knowledge that we had covered in class. The next thing that I want to chat about, and it's probably something that you've tried already, maybe you haven't, but they're relay races. So it prepares pupils for time pressured calculations. And as we keep telling them, you know, in the exams, it works out roughly, I think, about 1.5 minutes per mark. So we really want to start getting to grips with doing these questions under time pressure and practicing getting to grips with that. So what we'll do is we'll give them a certain amount of questions to complete in an allotted time, say 10 minutes, 15 minutes, and they pick a question card from the front, return to their desk, complete the question, bring it back with the right answer, and then move on to the next question. There's different ways that you can use it. If it's a particularly trustworthy class, you can have an answer key at the front for them to check themselves. What I've found myself sometimes doing with smaller classes is that I stand at the front and mark it quickly when they bring it to me and then give them the next card. But it's up to yourself how you manage those. That can get quite good fun and be quite competitive. What I would say about this one is that it's a good consolidation task to do when they're all fairly confident with it. I'm not a big fan of kind of competitions when we're starting out, because I feel like it puts a lot of pressure on some members of the class that are maybe really genuinely struggling with it and need a bit more practice. So this is the kind of thing that we'll maybe do the day before a test or something like that, just to have a little bit of fun once we've spent time already going over it. The next couple of examples that I want to show you are less calculation based, and they're used more to practice open-ended questions. Now, the two examples I'm going to show you are directed for our higher pupils, but they can be really easily adapted for National 5 and then, you know, advanced higher as well. So these are notorious with our pupils. I think it's a bit of a love-hate relationship. So the first one is a dice game that we use where we have a grid and we give each pupil 2 dice. I always forget which is which with dice, but they get 2, they roll them, and then they take the numbers and they basically find a point on that square there. So the 2 numbers might give them 4 and 3, so they'd go to along to 4, down to 3, and they'd get covalent radius. They'd roll the 2 again and they might get monatomic. Okay, and then what they have to come up with is a link between the boxes. Now, as you can see from the words in the grid here, some of the links are tenuous at best. Like, it can be really, really difficult to find these links. But what we find is that with practice, the links are there. Okay, and what they often have to do is delve into it a few layers before they can then find a link between 2 concepts. But it just really helps them with that kind of analysis that they need to be able to do for their open-ended questions, where they're asked to link 2 concepts together or relate 2 things or compare 2 things. So we found that has been really great with the hires, just getting them to grips with the Unit 1 concepts as well, as you can see from that one. So kind of your patterns in the periodic table, your atomic structure and the like. The other game that we like to do with that, which leaves everything a little less to chance and can be a bit more tailored to exactly what you want them to do, are these sort of consolidation hexagons that we do. So we can put the words in it, or they can put the words in it in any order that they want, depending on the class and what you think they would respond best to. And for each letter, they have to come up with the link between the 2 adjoining hexagons that meet at that letter. So again, this one doesn't really leave it as much up to chance. So if there's particular things that you want them to be able to link between, then you can place the hexagons in a way that does that. And as I say, we use this a lot for our hires with the Unit 1 stuff, but it can be used for National 5 as well. And again, it's just a template. You can pretty much put anything into there, and it just gets some thinking and kind of a bit more higher order stuff about how things link together and can be used to explain each other. The last thing that I want to mention is our challenge grids. So this is used for a starter quite often for lessons, particularly hires when we have them for a double. So we'll pop this grid up on the board and we ask them, how many points can you get in 7 minutes? And the way that the points are graded is that they get 4 points for anything that they've done a while ago, 3 points for something they've done more recently, 2 points for something more recent still, and then 1 point for something that they've done in the last week. And it's interesting because they all tackle it in different ways. So some of them will start with the green and work their way up. Some of them will start with the red and work their way back. And some of them will just do it in the order that they're in the grid. And then we'll go over that together as a class to ensure that we've kind of all got that, got those questions down. So we use that quite frequently as well. I would say we probably start maybe 1 lesson every week or every fortnight with a challenge grid like this, and it's just really challenging them to think back a little bit further than what we've done the last lesson or a week previously. And it also acknowledges the fact that it is harder to remember something that you've done a little while ago, but it's also very important to remember something that you've done a little while ago, because when it comes to the prelims or the exams, you're going to get asked about all of it, whether you did it a month ago or 2 weeks ago or last lesson. Something that typically I remembered as soon as I sort of, well, it wasn't as soon as, it was on Monday morning when I'd already sent the presentation away, but I had a 7 period day and I wasn't going to make any changes. There's a couple of other resources that we use. One of them is a retrieval roulette resource. Now, I think that we maybe actually originally got that through Strontium. It might be an RSC resource. I'm not totally sure. But basically, we've got about 500 questions that all relate to various areas of National 5 chemistry. And the way it's set up in an Excel spreadsheet is that you can effectively choose random 5 questions from different parts of the course. And it'll display those. And then on the next tab along, it'll display the answers. So with our National 5s, that's another thing that we do. 1 lesson a week, we start it with the retrieval roulette and they get 5 minutes to answer 5 questions. And we can tailor the question range to particular areas of the course. So they could be asked about the whole course up until the point they've completed it, or they could just be asked about Unit 1 or Unit 2 or anything like that. So I forgot to pop this into the presentation, but I'll send it to Paul. Karen in our department took a lot of time changing that and making sure that it fits the course nicely. And Paul could kindly distribute that perhaps to all of you to have a look at as well. So a bit of a whirlwind sort of tour of those, but just some ideas to hopefully inspire you into using kind of these retrieval practice and consolidation techniques in your lessons. So yeah, if anyone has any questions, any thoughts, please feel free to share. If anyone's using any of these things already and finds they work particularly well or anything like that, then it would be great to hear about it. So yeah, thank you very much.
That's grand. Thank you very much indeed. Okay, we've got 2 more presenters. We're going to go slightly beyond 5 o'clock, so if anyone needs to head off, that's totally fine. Please say cheerio in the chat, because that's always nice to see people do. But if anyone needs to head off, that's fine. But we are going to go to, I think it's Adrian next. Let me check my list. Yes, it is. So Adrian, I'm actually going to stop sharing completely, because I believe that you are going to take over completely, which is great. So hang on, I need to take control and then go stop presenting. There we go. Adrian, it's all yours.
Okay, thank you very much. I'm going to live dangerously and not use a PowerPoint and try and do some live microscale chemistry experiments using a visualizer on my desk at home. So I'm going to flip down my camera here, and you should see a tray here with some microscale experiments, which I'll try and fit in the next few minutes. So I'm just going to jump straight into it with a precipitation reaction. So I'm going to put a little drop of water, a puddle of water, as Bob Worley would call this, into this sheet here. And I've got crystals of lead nitrate and potassium iodide. And the way I'm going to do this precipitation reaction is I'm just going to dampen the ends of these cocktail sticks and put a bit of lead nitrate at the end here and a little bit of potassium iodide here. So I only need a few crystals. Less is better with these types of things. And then I'm going to shove in the lead nitrate into this side, and it's less soluble, so I'll leave a little delay here. And then I'm going to put potassium iodide on this side, and we're going to zoom in a little bit so you can see what's happening, if I can get this back in focus. And this seems to have worked okay, but I don't know if you can see there, but you can see a yellow solid start to form in the middle of the sheet there. I'll try and move my camera so I can center that's better. So this has got a lot of really nice chemistry in it. You've got ionic lattices, you've got solubility, and you've got a yellow insoluble solid formed in the middle in a precipitation reaction. And you can get your National 5 chemists to look in their data book to see what the precipitate could be. In this case, it's lead iodide, and they could look at the spectator ions and score them out. You can also do this with junior classes for the signs of a chemical reaction. So often when they add the solutions of lead nitrate and potassium iodide, you tend to get that color change, and they recognize the color change, but they don't realize a new solid's been formed. But what I like about this is you just get this gradual appearance of this new solid precipitate forming in the middle. And you can do this for various combinations as well. You can also do these in solutions. So another one I'm going to show you here is the reaction of barium nitrate, a couple of drops of barium nitrate with sodium sulfate. So if I want to get a different color solid, I could add a different combination here. So I could go like that. In this case, I've got a white precipitate being formed in this as well. Now you can do this with other color change reactions with S1s to get nice colors. I've done this with potassium thiocyanate and iron nitrate to get a sort of dark blood red color. You can also do iron sulfate plus sodium hydroxide, which kind of gives you a greeny brown precipitate. So you can get a whole bunch of nice different colors being formed as well. You can also go into advanced hard territory by adding copper sulfate. So this is a couple of drops of copper sulfate to a dilute solution of ammonia. And you get this nice, as you can see, deep blue complex being formed here. So if you want to cover transition metal complex chemistry, you could talk about the D to D orbitals and the absorption of light and the splitting and so on, and why we get a deeper blue color as we add the ligands such as ammonia to it as well. So you could cover this with junior classes, signs of this is really conveying that a new substance has been formed. We're getting color changes. Another sign of a chemical reaction would be adding an acid to magnesium. Now there's no color change per se in this. However, if I drop in a little square magnesium into here, you can see that we're going to get some fizzing and evolution of gas being formed here. I can zoom in a little bit there too. Now you can do this to do a reactivity series of methods with metals. You could have zinc and copper in there, or you could have different concentration of acids in different drops to monitor the effect of concentration on the rate of reaction too. Now, one of the things to note about this reaction, it's an exothermic reaction, but it's difficult to shove a thermometer into it. So I'm going to do a neutralization reaction using a thermochromic strip. Yeah. So this time I'm going to add some sulfuric acid, which I've got somewhere here. Here we go. So I'm going to take 1 molar sulfuric acid, which I'm hunting around for amongst all the bottles. Here we go. And you'll see what happens. I'm going to add just 1 drop of sulfuric acid. You should see that. And then to 1 drop of that, I'm going to add some sodium hydroxide. So this is 1 molar sulfuric acid, and this is 2 molar sodium hydroxide. If I add this, you get this lovely green color change that you would get, if you pressed your finger on the sheet as well. So it's a nice way of showing that in chemical reactions, you're getting energy changes being formed. In this case, we're getting exothermic reaction as well, like I would get if I push my finger onto the sheet, like so. I think my house is quite cold just now, I'm not getting with the finger. So I'm actually getting a reasonable amount of heat being formed here too. Now, if I just go up a little bit here, this is the final reaction I do as a surprise for my students when they're doing the signs of a chemical reaction. So I've got chemical A, which I'm going to call this just now. And to that, I'm going to add another chemical, just burst that bubble, chemical B. Now, it looks as if nothing's happened originally, but if you wait a second or two, you get this color change, a delayed color change there. So this is a classical iodine clock reaction. So solution A is potassium iodate, and solution B is sodium metabisulfate plus starch. So it's a delayed reaction in which the iodine is released and it forms a blue-black complex with the starch. So there's lots of good things I like about this. It's easy to clean away. Doing this in 5 groups with test tubes, 10 test tubes per rack with brushes at the end. It's incredible. You're getting test tubes left in the sinks if you don't check. You just wash this down the sink very, very easily. The second plus about this is the instructions are on the sheet too. So this helps focus your attention to the experiment as opposed to looking at a PowerPoint or another sheet that could get wet. Another thing I like about this is that if I zoom out a bit, by the time you've done all these kind of experiments and sort of show them all like this, it's quite cosmetic looking. The pupils will ask to take pictures of this with their phones if they're getting all these nice colours and these nice drops. So you think, optimistically, I'm hoping they're taking pictures of this on their phones and showing to their parents and getting them involved and engaged in the chemistry that we're doing in class. But probably the biggest plus, and this is the game changer, I find using a visualizer. Using a visualizer was very useful when I had to teach online. So you can do experiments like this online, live, or I tend to record them after a while for absent pupils during online sessions I had to do over lockdown, which was a big plus when I was teaching students online during a pandemic lockdown. So I think the option of using a visualizer really helps present chemistry in a nice, elegant way that maybe complements the flashbang demos we all like to do and have seen earlier. So if anybody wants, I'll try and post some resources onto this. I think there's a book coming out by Bob Worley and David Patterson in January on microscale chemistry, but Bob Worley has a really good microscale website, microscale chemistry website, and there are webinars that Bob and I have done and Science on Stage articles if you wish to investigate that further. And that's me, Paul.
That's grand. Thank you very much indeed. That's some gorgeous demos there. I'm actually just looking up the website and I'll post that in a wee second. I think I found it. I think that might be one. I'll have a wee flick around and see if I can find that website and just make sure it's the right one. But yeah, that's gorgeous. Thank you very much indeed. I can totally see lots of us picking that one up. Okay, we are going to go to our last presenter of the day, which is going to be Kimberly. So Kimberly, I'll share your presentation and you're welcome to take control if you like. Or if you want to do the classic COVID briefing, next slide, please. Yeah, you can totally do that, right? So Kimberly, it's all yours.
Thanks very much. That should be me, I think. There we go. Okay, so when Douglas had asked me to do this, I was didn't know what to do. The colleagues and stuff were telling me worked examples, and we in Glasgow City Council, every child and every teacher has an iPad, so I was going to do that, and then Douglas told me someone from Miss Adams was coming, and then I thought, well, I can't really tell a granny how to suck eggs, so I was like, I'll try and find something else. So I'm going to take you through doing a kind of flame testing that myself and the technician had come up with after seeing some things on Twitter for a class who are probably the highest tariff our full school has seen. Loads of additional support needs that are all in the one classroom. And I'll go through and I'll share kind of what the kind of makeup of the class is. And as kind of student teachers or people early in their career, in terms of location and things like that, will be really beneficial. So the additional support needs of this class that I done it with, there were 13 young people in it. Every single one of them had at least one additional support need. So the additional support needs ranged from literacy difficulties, so were identified to be doing different programmes within the school and literacy groups, all the way through to major social and emotional behaviour needs, where there's some of them on part-time timetables within the school, etc. So I see them for science in the morning, Monday, Tuesday, Wednesday, because I would not be able to do a practical class with them later on in the school day. They wouldn't be able to focus. So the reason why I put this picture in is when you have a class like this with young people with such a wide range of needs, you need to have eyes like a hawk. So I'm hoping you can still see me, because it's popped up saying that, can you still hear me? Because it's popped up saying it's lost signal. So
oh, you're okay.
You can hear me? Yeah, it just popped up saying bad network. So your positioning within the class, you need to make sure that you're able to look around, that you can see everybody in front of you. Flame testing is usually in a spray bottle, so spraying it onto a Bunsen burner. I wasn't trusting them doing that. Red hot pieces of metal and dipping it in, wasn't trusting them with that, because they would most likely try and chase one another with red hot metal. So we're trying to come up with ways that it's practical, it gets them involved. Due to their range of additional support needs, it's really difficult to have things that they're writing down, so hands-on is really beneficial. So the first thing I would say, if you have something that is very kind of practical with a class that you do find difficulties with, have step-by-step instructions available for them to see on the board. So you can see there it's quite very step-by-step. There's the list that that was available on the board when I completed it. But another word of warning, no matter how good they are, if they're a higher class or they're an advanced higher class, demonstrate what you're wanting them to do before you set them off. So gather them together as a class down the front and go through the step-by-steps that you're asking them to do. So I would have this on my board that everybody is able to see, and I would go through and say, for example, Callum, what's the first step that I need to do here? And they would talk me through, and I'd be showing them how to do it and emphasising the safety. So what we had done is the technician had made up solutions of 5 different compounds. So we had lithium chloride, sodium chloride, copper chloride, calcium chloride and potassium chloride. And she let wooden splints soak in them overnight. So they were kept inside the prep room and we had wooden splints soaked in them. So they came into the classroom, they were not in the solution, they were taken out and they were put into dry beakers and set up on the bench for each group. There was a Bunsen burner and a large beaker of cold water. So that's what they had in front of them. So then, once we were all ready to go, they were given each kind of splint as they went along and they recorded the information in their table. So I'll go through and I'll show you kind of what it looks like for each one. So this first one here, if it lets me play it, there we go. So this first one here on the left-hand side was lithium chloride, was a 0.1 mole per solution. And you can see, I don't know if it's playing for you. You should be able to see, don't know if it is playing. If you can see it from your side, can you see it playing? No, right, do you know what no, do you know what I might do if it lets me? No, it's not letting me. So in the slides, basically, it's a wee video and it's just a wee boomerang of showing you when it goes in and when it goes out. But you can see the colour change there anyway. The good thing about it is that they put it in quickly and take it out. They're able to see the colour change quite clearly. And the splint doesn't really go set a light. So they can put that in and take it out and they would record that in their table. A word of warning, never put a splint that's been recently set on fire into a plastic bin because the bin bag will catch fire and it will be stinking for days. So that's why you've got the beaker of cold water, you immerse the splint you've just used into the beaker of cold water and it's all good. So the one in the middle was sodium chloride, 0.1 mole, same again, in and out, and they're able to record the colour change. And then finally, that one on the right-hand side there is a copper chloride solution. And that's a saturated solution. The 0.1 molar, we weren't really getting a good colour, so I would just recommend that it would be saturated. So if I go on to the next slide, Oh, that's that playing now. There we go. So you should be able to see them all there. So if I go on to the next slide, this first one here on the left-hand side is calcium chloride. Again, saturated solution, and you can see they're able to see the colour change there as soon as they put it in. And then my favourite one, where we had to get them to look very clearly, was our potassium chloride, and that's got volume. So that one's got potassium chloride. You can see the lilac around about the outside, but the main thing that was emphasising, as soon as the splint becomes lit, you've left it in too long and you won't be able to see a colour change, and they then immerse that into the beaker of cold water. So it makes it dead easy for cleaning up. All you're doing is getting them to bring down their splints, and they can put them straight in the bin straight away. There's no need of it running it under a cold tap or a bin bag going on fire. So I thought that would be really helpful for folks who are early in their career or trying to look at other practical things about kind of planning really disruptive class behaviour management problems, and having a dead easy but able to see experiment. And another wee additional insight, you can do that with National 5, but I done it with a second year class. We done it around fireworks night, and then I got them to make up their own firework. So what colours do you want in your firework? What's going to be the name of it? And they had to tell me what metal splints they had to get to make their firework, and they then fanned that out and just passed it through the flame, and they were able to see their mixtures of colours. So that's kind of the ideas that I had, but I've left my email address there in case anybody has any questions or anything else that they would like to add.
That's grand. Thank you so much, Kimberly. Well,
No,
that brings us to the last of our speakers for today. I don't know if Douglas is still knocking around. I don't know if Douglas wants to say anything before we all depart. Are you there, Douglas? Apparently not. Oh, no, there we go. No, there's Colin.
No, I thought that was fantastic tonight. Absolutely inspirational. I'm kind of I'm thinking, you know, which of those ideas am I going to be thieving to pass on to PGDE chemistry students, I think, in the future, because there's some crackers there, some absolute crackers. And it's inspirational to see that. I've got hundreds of tabs open on my other screen now to look at, like the webinar that Adrian was sharing, and Dave Patterson's integrated instructions. I've used them before and I love them. I think they're fantastic, and I'm looking forward to that microscale book coming out. But no, I just thought that was really, really good tonight, and I hope everyone found it useful. I know if I was still in the classroom, that's the kind of CPD I liked, you know, just hearing what other teachers were doing and just being able to nick ideas off of folk. And I think that was ideal for that tonight. So thank you to everyone that presented. I don't know if Douglas has got anything he wants to add, or if he's used up all his technology for today or what. No, there he is. There he is.
Has Douglas used up all his technology? I'm on mute. I think I have.
I know you're there. We can hear you.
Well, thanks very much. I thought I had used up all my technology, but as I say, I was confident it would be really good, and thanks very much. But as Colin had said, wow, the thanks. I mean, it goes beyond my expectation, but maybe that's not what I should say, but it really, really was absolutely fabulous. And I hope we can do this again. And I hope that one thing I've noticed, I've been in 10 schools recently, and 8 out of the 10 were not aware of these workshops. So we have a job to do with regards to marketing this project. And it's something that's clearly we need to think about. We're hoping to have at least 2 in the new year, one to do with structure and bonding, one with chemical calculations, but we clearly have other challenges, including, you know, how we actually market what we're doing. I've got unmuted.
No, we can hear you fine, Douglas. Oh, he's vanished now. Oh, well, there we go.
Enjoy the rest of your night.
Yes, and so thank you very much for attending. As everyone said, a really nice variety of stuff as well. Some sort of whiz-bang stuff and some more kind of in the classroom sort of day-to-day stuff as well. So quite a nice mix. Thank you again, everyone, for attending. I hope you have an amazing Christmas and a superb New Year. And oh my God, is it not more deserved than it almost ever has been in terms of anybody's career. Please do not forget to depart the call with the customary Zoom wave, and we will see you on a future occasion. Thank you very much, everybody, and good evening.
Thanks again. Bye.
Thank you so much, folks. Thank you.
Everyone. Great stuff.
Thank you, everyone.
Bye-bye.
Thank you, everyone.
Thank you.
I know.
Thank
See
you.
you later.